Hey, Cherry Creek Math Department, Mr. D coming at you from the CCIC. I want to show you something cool here we're doing in our construction class, and it's application of finding the complement of an angle. Specifically, we're cutting rafters. So let me show you this cool lesson coming up. So we have this little mock-up build here. This is a rafter that'll support a roof, a little shed roof above an entryway. But let me tell you some of the parts real quick that we're looking at. This right here at the top where the rafter meets the ridge is called the plumb cut. And you guessed it. Why do we call it plumb? Because it's perpendicular to the ground. If I were to drop a line all the way down here, then you'd see where it hits perpendicular. We talk about pitch when it comes to rafters. In this case, it's always set to 12 inches. So what is my rise for every 12 inches I run? In this case, this is called a 6 and 12 pitch. So for every 12 inches I run across, 6 inches I rise. I want to talk to you about the complement here. And this is kind of a fascinating concept that we just found a really cool application for, is this concept called the seat cut. So the seat cut is where the rafter will bed down on whatever's supporting it, in this case a 4x4 post. But I want you to pay special attention to this is another plumb line here at the same 6 and 12 pitch. And most importantly, the seat cut needs to be perpendicular to that plumb line so that it beds down nicely on top of that post. So let me show you kind of how we do this with our speed square. So what you'll see me do first is consult my speed square here for marking out my rafters. These numbers right here that go along the bottom of this common side, they represent my pitch in inches. So if I want a 6-inch pitch, 6 and 12, then I'm gonna pivot my rafter square to draw a plumb line to that 6 value. Okay, you'll see me doing that here. I line up in the corner, rotate until I get to the 6, that's a 6 and 12, and that first mark there is my plumb line that you saw earlier. So that's gonna be my first cut. I'm gonna move down my rafter, the length of my adjusted rafter. How do I know my length, you ask? Well, my good buddy Pythagoras here helps me out by knowing my rise over my run. A squared, B squared, and C squared help me find the length of my rafter run. Also, this handy dandy construction calculator does it all for me. So I'm gonna do that same same plumb line over here. I pivot at my mark. I'm gonna rotate until I get to my 6 on my common scale, slide to my pivot, and same mark there. So now I need, if you remember, what I call that seat cut. And this is where the complement comes in, okay? So I'm looking for a line to come perpendicular off this that's 3.5 inches for my rafter to seat on, okay? So you'll see this here. If I pivot, I can no longer get to a 12 value on my speed square, okay? And I know I need a perpendicular line that's 3.5 inches. So what do? I find the complement of my angle, okay? I know that a 6 and 12 pitch is 26.5 degrees. How do I know that? With a little bit of trigonometry, okay? I've got a 6-inch rise, a 12-inch run, and my inverse tan tells me that it's 26.5 degrees. And by the way, all of those values are marked on my rafter square here too. So a 6-inch run, 6-inch pitch, 26.5 degrees, okay? So I know that the complement of 26.5 degrees is 63.5 degrees. Now check this out. We're gonna go back to our plumb line and we're gonna pivot until I reach the perpendicular complement at 63.5 degrees here. If you see this, 55, 60, 61, 62, 63.5, and I'm gonna slide my rafter square until I get exactly to 3.5 inches, and that right there is a 3.5 inch seat cut that I was looking for. And that's how you apply the complement of an angle to cutting rafters.